Hi, this is Mr. V. Today, this is Algebra 2 Honors Summer School, Day 13, and this is part 2 of my lecture where I'm actually going to go through some sample problems with you. And if you'll bear with me, we try to do this. This first one, we're not going to write as a polynomial. We'll try to rewrite these as a quadratic, and then we can use quadratic rules to solve it. So if I substitute in this first problem, if I let u equal to a squared, I could rewrite this as u to the fourth plus 10u minus 16. And this is clearly not a quadratic. And I don't know how to simplify it any more than this. So I'm not able to do this one. This is not one that I can rewrite. Let's try the second one. If I let u equal to x to the 1/9, then u squared would be equal to x to the 2/9, or u cubed would equal to x to the 1/3. So I could rewrite this equation as 7u minus 3u cubed plus 4. And again, this is not a quadratic. This is not a good one to use quadratic techniques with. Looking at the last one, I'm going to let u equal to x to the 1/5. And if I go to the 1/5, then I would say u squared would equal to u to the 2/5. So I could rewrite this as 6u squared minus 4u minus 16. To solve this, I would want to factor it, and I could factor it by going two numbers that multiply to give me 6 times 96, negative 96, and add to give me negative 4. And if I look at this, I'm going to say 12 and 8, so then 12 would be negative. My leading coefficient is 6, so I'll put a 6 under both of these and redo this. This becomes 4 over 3. This becomes negative 2 over 1. So my factors are u minus 2 times 3u plus 4. And you'll notice my u squared, this does not get me to 6. I have to multiply everything by 2. A 2 factors out of all of this. Well, then I could actually solve for u, and I guess it says to rewrite it as a quadratic. That's all we had to do. But you could actually solve this. You could say if u is equal to 2, then I would have x to the 1/5 is equal to 2. So x is equal to 2 to the 5th power. Or you could say if u is equal to negative 4 over 3, and that's u to the 1/5 power, that's equal to x to the 1/5 is equal to negative 4 over 3, then x is equal to negative 4 over 3 to the 5th power. So there we have it. Two answers. Here we're supposed to solve this. And so I'm going to rewrite this, setting it equal to 0. I have y minus 19 root y plus 60 is equal to 0. And to do this, I want to substitute in, let's let u equal to the square root of y, in which case I would have u squared is equal to y. So I could rewrite this as u squared minus 19u plus 60 is equal to 0. And in the interest of time, let's use the quadratic formula, which says my x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a over 2a. So I can substitute these values in to find these zeros. So if I have negative b, that's 19 plus or minus the square root of b squared, which is negative 19 squared. 19, which is 361, minus 4 times 1 times 60, which is 240, all over 2 times 1, which is 2. So my roots here would be 19 plus or minus, let's see, this. If I have 361 minus 240, I get 121, which is 11. So I have 19 plus or minus 11 divided by 2. That's going to be 19 plus 11 would be 30. Divided by 2 is 15. Or I could have minus that would be 8. 8 divided by 2 is 4. So my U value is equal to 15 or is equal to 4. So when we go to do the plug it back into our original equation, we have the square root of y is equal to 15, or the square root of y is equal to 4. When I square both sides of the equation, I'll get 15 squared, 225, or I get the 4 squared, which is 16 for y. Okay. The second equation, if I let u equal to b squared, I'm going to have u squared minus 9 is equal to 0. And this could be factored. It could go u plus 3 or u minus 3 is equal to 0, in which case u is either equal to 3 or u is equal to negative 3. That means that b squared is equal to 3 or b squared is equal to negative 3. When I square root both sides, I'm going to have a plus or minus. Here I'm going to have a plus or minus the square root of 3. Here I'm going to have plus or minus the square root of negative 3, which is the same as plus or minus the square root of 3i. So there's 4 roots, and you'd expect there to be 4 roots because this is a quartic equation. Next example, use synthetic division to find the value of g when you put in 3 for x, when you put in negative 4 for x. My coefficients here are, for this first one, are 1. The coefficient of x to the fourth is 0. You have for the coefficient of x cubed is 8, of x squared is 0. The coefficient of x is 2, and the constant is negative 15. When I divide this by 3, to do the substitution, there's a video on it to show you how to do it. I'll multiply 3 times 1 and get 3. 3 times 3 is 9. This is 17. 17 times 3 is, what is 17 times 3? 21, 51. 51 and 50. 51 times 3 is going to give me 153. This is 155. And 155 times 3, I'm going to use my calculator. 155 times 3, and that's 465. And subtract 16 from it, 465. I put 15 from it, and I get 450. And that's how short it should take you to do this synthetic division to find out the value of g of 3. G of 3 is equal to this. I'll do another one for you, just one more instead of doing 2 more. I could do this second one with negative 4. So we'll do, my coefficients are 3, 1, negative 2, 1, and 12. And the number I want to divide into this is negative 4. Notice this is not the factor. This would be the x value. If x is equal to negative 4, my factor would be x plus 4 is equal to 0. So this would be the factor. So when I'm substituting the number in, I do it this way. So I have 3 times negative 4 is negative 12. Here we have negative 11. This is 44, 42. 42 times 4, 42 times 4 times a negative 4 is negative 168. Negative 168 plus 1 is 167. Negative, if I'm doing this right. And then I multiply that times 4, and I get 668 negative. And so it looks like my answer, if I did this correct, is going to be 656. But you get the idea. And so this would be my g of negative 4 for the second one. This is for the first one. Okay? Given a polynomial and one factor, find the remaining factors. So I'll do this first one for you. The coefficients are 1 negative 1, negative 10, and the constant is negative 8. If x plus 1 is one of the factors, that means that negative 1 would be one of my solutions or roots, and I can plug that in here. I get 1 times negative 1 is negative 1. This would be negative 2. Negative 2 times negative 2 is going to give me 2, and this will give me negative 8. Negative 8 times negative 1 is 8. My remainder is 0. That means that this indeed is one of the factors. What this line means is that since I've divided it by x already, I'm going to have 1x squared minus 2x minus 8. And this is something that I can factor. If I have a negative 8, what two numbers multiply to give me negative 8 and add to give me negative 2? Well, that would be negative 4 and 2. So my factors are x minus 4 and x plus 2, and that's equal to 0. So x is equal to 4, or x is equal to negative 2. But I'm asked to find the other two factors. So there you have them. Find k when the remainder is 3. Again, this is my factor, so my x value is going to equal to negative 2. So I can do this synthetic substitution. I have 1, 4, 1, and k. And I'm going to substitute in negative 2 here. When I do that, I have 1 times negative 2 is negative 2. 2 times negative 2 is negative 4. 4 is negative 3. Negative 3 times negative 2 is going to give me 6. And my remainder, so this is going to be 6 plus k. And if you want to think of it this way, you could rewrite this whole thing as, not that we have to do this, you could write this as 1x squared plus 2x minus 3 with remainder 6 plus k over x plus 2. 6 plus k. Now what I'm supposed to do is find the remainder here when x is equal to, the remainder is 3. So 6 plus k has to equal to 3. Well, a k value of negative 3. So k is negative 3 is my answer to this. A couple more examples. Find all the possible real roots, possible negative roots, and possible imaginary roots. It's been a while since I've done this. I don't know if I'm going to be able to do this or not. If x is a positive number, this is a positive. This goes to x is a positive, this is still a positive. If x is positive, this is a negative. That's one change of sign. And then it goes to a positive. That's another change of sign. So I have 2 or 0 possible real roots. Positive. Positive real roots. If I substitute in a negative value, so I would start off with a negative number. I end up with a positive here. A negative times a negative is a positive, and a negative is a positive. I am going to have one negative real root. And any way you look at it, you're going to have one negative real root. The question is imaginary roots. Well, you have to have a total of 3 roots. So imaginary roots, you're going to have the root and its conjugate. So it could either be 2 or it could be 0. And all of these add up to 3. So these are the total possible numbers that we could have. Find all the zeros of the function. Oh my goodness. Well, do you know what I'm going to do? I'm going to graph this on Desmos and see what they are. And then I'll actually work through it if I need to using synthetic division. But that's how I'm going to solve it. And I'll let you do it. Write a polynomial of least degree with this as a factor and this as a factor. That means that x is equal to 9, in which case x minus 9 is equal to one of the factors. Or x is equal to 1 plus 2i, in which case x minus 1 plus 2i is a factor. And if this is a factor, its conjugate has to be a factor. Well, the conjugate of this is x would equal to 1 minus 2i. So I could write this as a factor would be x minus 1 minus 2i. And so let's work it out. We have x minus 9 times x minus 1 plus 2i times x minus 1 minus 2i. And when we multiply these out, let's start by multiplying these two. I'm going to use a box to do this. X minus 1 plus 2i. X minus 1 plus, oh, this should be minus, plus 2i. So we have x squared, negative x, negative 2ix. Here we have negative x plus 1 plus 2ix. On the bottom, we'll have 2ix minus 2i. I'm sorry, this should be just 2i. And then we have a negative times a negative is a negative 4 and a plus 4 because it's a, so this will multiply out to be, this is equal to x squared. These are like terms, minus 2x. These two terms cancel. These two terms cancel, plus 4. So I have a real coefficients. And I'm going to take this polynomial and multiply it by x minus 9 to get x cubed minus 2x squared plus 4x minus 9x squared plus 18x minus 36. And when you combine all of those together, the x cubed, here we have like terms, minus 11x squared. Again, this should be x. Like terms would be plus 22x minus 36. And there you have it. Good luck and success.